Welcome to today's lesson. In this video, we are going to be introducing momentum and work out a couple of examples to help you familiarize yourselves with the equation of momentum. Now, let's start with the definition of momentum. The definition of momentum is the tendency of an object to keep on moving. But by looking closely to the definition of momentum, one can easily identify the two quantities that momentum is dependent on. Every single body in physics is considered to have a mass, and if for an object to have momentum it has to be moving, then that body must also have a value of velocity. Now let's look at the relationship between momentum and mass, and the relationship between momentum and velocity. Momentum and mass are directly proportional, and therefore the greater the mass, the greater the momentum. Similarly, the momentum and velocity are directly proportional, and therefore the greater the velocity, the greater the momentum. Now let's look at the equation and units of momentum. The equation of momentum is a very straightforward and simple equation. The equation is momentum equals mass times velocity. The symbol of momentum is P and not M. M is the symbol for mass. To derive the units of momentum, one has to look at the units of both mass and velocity. The unit of mass is the kilogram, and the unit of velocity is meters per second. Therefore, if we multiply kilogram with meters per second, we get kilograms meters per second, which is the unit of momentum. The equation of momentum also shows us that momentum is a vector quantity, as you can see with the arrow over here. The reason why momentum is a vector quantity is because momentum is dependent on velocity, which is also a vector quantity, as this arrow is showing over here. A vector quantity is a quantity that has both magnitude and direction, and if you're looking to understand better the difference between vectors and scalars and how to derive units, stay tuned for the upcoming videos. Now, since the equation of momentum is a three-quantity equation, it can be mathematically manipulated using the triangle. Remember, to use a triangle, you need to hide with your hand the quantity that you want to find. For example, if you want to find the momentum, you hide P with your hand, and you see that it can be calculated by multiplying the mass with velocity. Similarly, if you want to find the velocity, you cover V with your hand, and you see that it can be calculated by doing momentum division by mass. Now, to help you practice how to manipulate this equation, let's work out the following examples. Okay, so let's look at the following three examples. Let's look at example number 1 first. So a car of mass 1,200 kg is driving with a velocity of 2.5 meters per second. Calculate the momentum of the car. Ideally, the first thing you do is that you write down the value of mass and velocity on the side, so you'll know exactly what information you are given in the question. So in this case, we have mass equals to 1,200 kilograms, velocity is equal to 2.5 meters per second, and we need to find the momentum. We write down the equation of momentum, and the next thing that we have to do is we have to replace letters with numbers. So momentum we still need to find, so we'll leave it as P. Mass is 1,200 kilograms, and the velocity is 2.5 meters per second. Multiplying 1,200 with 2.5 will give you an answer of 3,000 kilograms meters per second. And that is the answer for example number 1. Okay? Now, let's look at example 2. Example 2 asks us to calculate the velocity with which a car is driving. So, let's read the question. A car of mass 2,000 kg has a momentum of 4,000 kg meters per second. Calculate the velocity with which the car was driving. Again, we write down the quantities provided. So we are provided with mass, which is equal to 2,000 kilograms. We are also provided with the momentum, which is 4,000 kilograms meters per second, and we need to find the velocity. Now, for this example, you can make use of the triangle, or you work out with the equation using subject of the formula. So we have P equals m times v. We need to find v, so we need to remove m from this side of the equation. Therefore, from multiplication, if we take m to the other side, it will become division, so that will become momentum division by mass equals velocity. Now, the next step would be to replace letters with numbers. So, 4,000 division by 2,000 equals v, which is equal to 2 meters per second. And that is the answer for example number 2. Let's look at example number 3. A car was driving with a velocity of 4 meters per second and has a momentum of 4,000 kilogram meters per second. Calculate the mass of the car. Again, this time we have to write that we have a velocity of 4 meters per second. We are given the momentum, which is equal to 4,000 kilogram meters per second, and we need to find the mass. We start with the original equation of momentum. Now we need to make sure that we make the mass subject of the formula. So we need to remove the velocity from this side of the equation. Now velocity and mass, they are tied with a multiplication sign. Therefore, if we remove the velocity from this side of the equation and we put the velocity on the other side of the equation, that will become a division. So momentum division by velocity is equal to mass. Momentum is 4,000, velocity is 4, and therefore we end up with a mass of 1,000 kilograms. That concludes today's video, which introduced you to what is momentum and its equation. I hope you understood what was discussed. Stay tuned for part 2, where we'll be discussing the conservation of momentum and the type of collisions.